All right, Tuesday, March 24th, 2020. I just want to give you guys some helpful review before we go into the right triangles with radicals in them. So just to make it clear, so this is 5 radical 2 quantity squares. So I'm going to expand it first before I show you guys a little quick trick. So I'm just going to put these problems out here really quick. So 5 radical 2 quantity squared. Oh, I just knocked down the notebook. No, we're not doing calculus today. So let me just make it clear. There we go. Good old iPad. So think about this. If I have a number inside of parentheses and it's getting squared, that means that it's multiplied by itself. So if I square a number, that means I multiply 5 radical 2 times 5 radical 2. So let's just multiply numbers with numbers. 5 times 5 is 25. I don't know the square root of 2. Sorry, let me just go into my chair. Sorry about the shaking camera. I don't know the square root of 2. However, I do know that if I have the same number in the radical, I can factor them out and make them twins and make them a whole number. So this is radical 2 times radical 2 becomes just 2. Think about it. If I have a nice square root like 9, radical 9 times radical 9 is 9, or I could look at it radical 9 as 3. Radical 9 times radical 9. Yeah, I got that right. Radical 9 times radical 9 is 9 because the square root of 9 is 3, and 3 times 3 is 9. Anyway, I didn't want to confuse you. But the idea is if I can square the number inside the radical, it just pulls out. And then 25 times 2 is 50. See if you guys can do the same thing with 7 radical 3 quantity squared. Okay? Well, remember, if I square a number, let me just show you the quick trick. That means that it's 7 radical 3 times 7 radical 3. Why don't I just do this? 7 squared, radical 3 squared. So that'd be 49. I don't know what the square root of 3 is, but I do know that if I take whatever the square root of 3 is and then I square it, it's just going to be 3. So 49 times 3, well, if 50 times 3 is 150, then take away 3 from that. That'd be 147. Okay? 4 radical 10 squared. Well, I could do this, again, I'm just going to level up my character. I could approach this as 4 radical 10 times 4 radical 10. You know what? I think I'm starting to get the hang of this. I'm going to square the 4, and I'm going to square the square root of 10. So this literally becomes 4 squared, which is 16. And then radical 10 getting squared is just, well, 10. So this literally just becomes 160. Well, using a variety of ways, you know that you can always mirror it, multiply the coefficients with the coefficients and the radicals with the radicals. You can square each individual factor and then multiply them. Or you know what? You can get really, really good at it. You can do it in part 3. You pick the method that works best for you for 2 radical 15 quantity squared and 3 radical 11 quantity squared. Tell me which is the best fit for you. Okay, well, let's try to do this. If you did this correctly, you should get, I like the method number 3 because I'm getting pretty good at this. That'd be 2 squared, which is 4. And then radical 15 quantity squared is just 15. So 2 radical 15 quantity squared should be 60. Same thing over here. 3 squared is 9. Radical 11 quantity squared is 11. 9 times 11 is 99. Now, why am I showing you that? Well, because it's going to help with the right triangles. So let's do some problems. So let's say I start off with something easy. All of them are whole numbers. The directions are going to say, evaluate the 6 trig functions for the angle theta. So sine, cosine, tangent, cosecant, secant, and cotangent. I was going to have you guys do Pythagorean theorem to solve for the unknown side, but I just wanted to see if you guys remember how to do this. So we're going to look at the angle theta. We're going to do the sine ratio. So if you want to put sol, ka, toa, then do so. Sol, ka, toa. That might help me out too. So let's take a look at the sine ratio. The sine ratio is an angle's opposite side to its hypotenuse. So the sine ratio should be 10 over 26. Now, could you reduce this to make this 5/13? Absolutely. But you know what? We have bigger fish to fry. Cosine of theta. That would be the adjacent side of theta to its hypotenuse. So that'd be 24 over 26. Okay, and tangent. The tangent of angle theta would be the opposite side over its adjacent side. So that'd be 10 over 26. Now, again, you could reduce these fractions. I'm not so picky about that. But what I do want you to understand is the reciprocal of sine is the cosecant ratio. So we're going to take the sine ratio, flip it, and that's our cosecant. So if the sine is 10/26, then the cosecant would be 26 over 10. The secant is the reciprocal of cosine. So what is the reciprocal of 24/26? That'd be 26/24. And finally, the tangent is 10/26. So what is the reciprocal of the tangent ratio? In this case, the cotangent. So what's the cotangent of angle theta? There we go. Now, I'm not going to be a nice guy. When am I? So sometimes a diagram might look like this. I've got angle theta. The book didn't give me any units, but I want you guys to focus on the steps as opposed to like whether it's in inches or centimeters or whatever. So let's just pretend it's 8 inches and 3 inches. Well, what's missing? This side right here. So let's take a look at the Pythagorean theorem. We need to do leg squared plus leg squared equals hypotenuse squared, not hippopotamus squared. I know you guys missed that. So what information do we have in this diagram? 2 legs or 1 leg, 1 hypotenuse? Well, I've got 2 legs. And let's just say I call the third side x because I don't know it. So the diagram will be given with like the angle theta and 2 of the sides. So when in doubt, just put x for the unknown side. So I'm going to say 3 squared plus 8 squared is equal to x squared. 3 squared is 9. 8 squared is Nintendo 64. And x squared is, well, just x squared. 9 plus 64 is 73, not 63. That would have been a bad move. So 73. Sorry about the... So 73 is equal to x squared. How do I solve for x? I'm going to square root both sides of the equation. Now, can I divide anything out of 73? No. Let me just see. Is 73 prime or composite? It is a prime number. I just looked it up on the computer with my right hand. So 73 is a prime number, so x is equal to the square root of 73. So x, sorry about that. So x is equal to the square root of 73. But is that what I'm asking for? No, all it means is that in our updated version of the triangle, we still have 3, 8, but the hypotenuse is the square root of 73. If the square root of 64 is 8 and the square root of 81 is 9, so the square root of 73 is somewhere in between, but you know what? I can't really simplify that radical. So let's do the sine, cosine, and tangent ratio as well as its reciprocals. So I'm going to do that over here. So I'm going to do the sine of theta, cosine of theta. Actually, no, I got space. Cosine of theta, tangent of theta, cosecant of theta, secant of theta, and cotangent of theta. So now, let's look at the diagram and solve. So, I'm going to look at the sine ratio. See if you can find sine, cosine, and tangent independently. Okay, looking at this diagram, 3 is the opposite side, 8 is the adjacent side, and the square root of 73 is the hypotenuse. So the sine ratio, the sine of angle theta is 3 over radical 73. So that's my sine ratio, 3 over the square root of 73. What's the cosine ratio? So the cosine is 8 over the square root of 73. The tangent is the ratio of the angle's opposite side to its adjacent side. So that's going to be 3/8. And you know what the best part is? I don't even have to look at the diagram anymore, because I know my sine, cosine, tangent. I know cosecant, secant, and cotangent are the reciprocal trig functions. So I'm going to do the reciprocal of this and make this square root of 73 over 3, square root of 73 over 8, and 8/3. Do you understand? You understand so much you overstand. Okay. All right. See if you can do number 3 independently. This time you've got 10, 9, and let's put an angle theta. I'm going to put the angle theta right there, actually. I'm going to be a mean guy. See if you can do this problem independently now. Okay. Sorry, I'm going to put my updated triangle down here. So, what's missing in this triangle? Well, I've got a hypotenuse, I've got a leg. I don't have this leg. I'm going to call it x. So, I'm going to use Pythagorean theorem. Leg squared plus leg squared equals hypotenuse squared. So that's going to be x squared plus 9 squared equals 10 squared. So I've got x squared plus 81 equals 100. I'm going to solve for x now. Unfortunately, I have to do a little bit of algebra. It's not going to hurt me that bad, though. So I've got x squared. 100 minus 81 is 19. So how do I undo that x squared layer? I'm going to square root both sides. And 19 is also a prime number, and I can't factor anything out. So x is equal to the square root of 19. But are those the directions of what I'm asking? No. So I'm going to look at this triangle. I'm just going to update it with the information. And I know that this part right here is the square root of 19. Now, can I do SOHCAHTOA? Oh, yes, I can. So I'm going to evaluate. I'm going to do sine, cosine, and tangent. And then I'm going to do cosecant, secant, and cotangent. Okay, now let's take a look at the diagram at the same time. Once again, I'm looking at angle theta. What is the opposite side to its hypotenuse? Radical 19 over 10. What is the adjacent side to its hypotenuse? 9/10. What is the opposite side to its adjacent side? Radical 19 over 9. And finally, we're just going to look at these and make our reciprocal trig identities. Remember that the reciprocal of radical 19/10 is just 10 over radical 19. And the secant is the reciprocal of 9/10, 10 over 9. And the cotangent is going to be 9 over square root of 19. Any questions? Feel free to email me. Okay. Turn it over. Did those problems. Okay. Did the last problem of the day. I want to see if you guys can handle this. In this case, I've got 2 radical 17. I've got 8. I don't know this. I'm going to call it x. So I'm going to do Pythagorean theorem to solve for the unknown leg. Oh, wait a minute. So that means I have to do 2 times the square root of 17 quantity squared. Luckily, I had those helpful examples that are going to come in handy for this problem. So I've got x squared. 8 squared is Nintendo 64. What is 2 radical 17 quantity squared? Well, 2 squared is 4. Radical 17 quantity squared is 17. So that means I've got x squared plus 64. And I'm going to get a calculator. Well, actually, you know what? If 2 times 17 is 34, I'm just going to double that. That's going to be 68. So 4 times 17 should be 68. Now I'm going to get x isolated by subtracting 64 from both sides. So that's going to get me x squared equals 4. How do I isolate x now? I'm going to square root both sides. Square root of 4 is 2. So that means that this unknown side length is going to be 2. So I'm going to draw myself a new triangle just to update the information I had because I like seeing things in one place. So I've got 2 right here, still got 8 here, and 2 radical 17. And all I know is that this is a 90-degree angle, and this is my angle theta. So now I'm going to find sine, cosine, and tangent. So my sine is going to be the ratio of 2 over 2 radical 17. Now, if you wanted to simplify this to become that 2's cancel out and make it 1 over the square root of 17, be my guest. But you know what? The bigger picture is to know what the sine, cosine, and tangent are useful for. Is to solve for the unknown angle in this case. But I'd rather you just tell me the sine, cosine, tangent, unless you really have an urge to simplify. I'm not going to get mad. The cosine of angle theta is the adjacent side to its hypotenuse. So that'd be 8 over 2 radical 17. If you wanted to simplify this and make this 4 over radical 17, be my guest. I'm not going to get mad. Now the tangent is just opposite over adjacent, so that'd be 2 over 8. You could make this 1/4. The cosecant of angle theta would just be the reciprocal, 2 radical 17. over 2. The secant. So I guess the cosecant ratio would be radical 17 over 1, or just radical 17. Secant is the reciprocal, so that'd be 2 radical 17 over 8, or radical 17 over 4. I'm not going to stress too much about simplifying a fraction. Cotangent is the reciprocal of 2 over 8, so that'd be 8 over 2. That'd be 4 over 1, or just 4. I'm not going to get too picky about simplifying a fraction since you know how to do that. I'd rather you focus on the big picture. The only reason I'm going over the simplifying radicals is because the SAT goes over it. So, again, don't hurt yourself over trigonometry. I care about you guys. Anyway, that about concludes it for today. I hope you guys have a great Tuesday. See you guys on Thursday.